So today we will discuss about the application of the wave-like properties of the particle, and the theory we have discussed already. And what is the name of this theory? The wave-like properties of the particle, the broglie equation. Okay? And now we are going to actually what is the purpose of this theory. Actually we have in a very brief equation we have established the relationship between the particle and the wave-like. So the particle as an electron is having the wave-like properties. So if it is having the wave-like property, actually what is the purpose of this one, and what is the outcome coming out this wave-like properties of the particle, and the application is the development of the electron microscope. So let's see, first with this we have already discussed in the first class. These are the different electromagnetic radiations. So you just have a look over here. This is the atom. Now the purpose is to see the atom. We cannot see the atom by using your naked eyes, because we are with our eyes you can see only the visible range, and visible region is 400 nanometer to 700 nanometer. So if the wavelength and these virus, bacteria, and the atoms, molecules, all are existing above this visible range, that means they are having more shorter wavelength as compared to the visible range, or having the energy is high and the wavelength is short. This is actually the relationship between the Planck's different parameters, Planck's equation here. Now the purpose is how can we see this one, and these are all these above this visible we have the ultraviolet, we have the x-rays you can use, and in the hospital you use the x-rays to get the x-ray of your, like, let's suppose bones. Okay, so and these are the electromagnetic radiations. Gamma rays you have, this is also but is the radioactive, or you can say this is one of the radiation coming from the nucleus, and all these are coming from the outer nucleus, that is due to the presence of the electron in the core shells or the outer shells. This we have in detail we have discussed in second or third class में. नहीं है तो आप जाके वहाँ पे दोबारा से इसको देखें. And this is very important to have the relationship and the development of the different electromagnetic radiations. Now have a look. Actually, what is the purpose of this one? The wave-like properties of the particle, and the particle here we are considering as the electron. So actually, we want to see how virus looks like, how the atoms look like, and what is the shape or the structure of the other molecules. And this is the picture I have shown over here in the previous slide. So actually these are the different, maybe the atoms or the molecules, or but present at the nanoscale level. And you cannot use the light microscope or the x-rays to visualize all these atoms. X-ray भी आप लेते हैं, आपके देखें बोन्स का लेते हैं, आपके आते हैं वहाँ पे कभी भी आपको इलेक्ट्रॉन्स या आपके पास जो प्रोटॉन्स हैं, न्यूट्रॉन्स हैं, या उनका स्ट्रक्चर इन डिटेल इन डेप्थ जो है आपको नजर नहीं आएगा, एक इमेज आपके पास आएगी. That means X-rays, somehow these are the sufficient to get the image, but how can we further go to in detail the structure of the molecules with the how the atoms look like in the molecular form. So this is the electron microscope. अब इसको देख के हम आगे जो बढ़ेंगे. अब देखें ये हमने visualize करना है. Now what we are going to further modify the de Broglie equation. The purpose is to use the electron to see the atoms or the molecule which are present at the nanoscale level. So the first one, the most important part of the wave-like behavior of the particle. Wave or the wave does not has any charge, but the electron is having the charge. That means you can control this charge with the let's suppose with the battery, and battery you have the positive and the negative ends. दोनों terminal आपके पास हैं, ठीक है? So what is the purpose over here? you can control the speed of the electron by using the different voltage है, सही है, different voltage आप देंगे तो इसको आप accelerate कर सकते हैं, you can accelerate the electrons, देखें ये इसकी speed ही है, if you can control the frequency or the speed, that means you can control the wavelength of the particle, क्योंकि आपस में relationship है, ये सारा relationship हमने पहले establish किया, ठीक है, और किसमें फोटो इलेक्ट्रिक इफेक्ट में तीनों फिनोमेना हमने पढ़े, हाउ द इंटेंसिटी और द फ्रीक्वेंसी और द एनर्जीज आर रिलेटेड टू ईच अदर, उसको पढ़ें दोबारा से जाके, सही है, दोबारा यहाँ पे फोकस नहीं हम करें. But output of this one, that means electrons are present in the charge or are having the negative charges, so you can control or you can accelerate with the variation of the speed. यहाँ पे भी आपको यही नजर आ रहा है, that means this is, let's suppose this is an electron gun, that means this is a tube emitting the electrons, and you are going to control the acceleration by using this battery, and these are going to fall on the nickel foil or the nickel plate, and after this one these are they are deflected, or they may be remove the electrons from the nickel atoms as well, depending on their energy or their velocity, and they are going to fall on this plate, and this is called the receivers or the electron receivers. So actually the purpose of this is only the one objective, to understand you, that means you can control the acceleration or control the speed of the electrons with the batteries, because electrons are having the negatively charged, okay? And this you cannot control with the wave. If it is a wave, that means if the X-ray or the UV is passing, if you can maybe you can vary the voltage of the battery, these are not going to be dependent because of having no charge on the wave, ठीक है, indirectly हम इसको जो correlate कर रहे हैं. So this is the what I have already explained. When a beam of electron is directed through an accelerated electrostatic field, that means two parallel plates with potential difference of volt, सही है, ये potential जितना भी है, it is going to depend what voltage you are going to apply. Similarly, we have the 100 watt or 1000 watt, or how much voltage you are going to apply, and you can get similarly the high visibility depending on the what is the watt you are going to use to get the light which is coming from the bulb or the LED. So the potential energy gained by each electron, and this is called the potential energy is electron volt, and can be equated to its kinetic energy, और उसके जो है ये kinetic energy में जो है convert है, मतलब आपके पास again the electrons is coming from the electron gun. So if you applied the more voltage, that means the electrons are being injected from the electron gun, and if you applying more voltage, so where it is going, this is converted into the kinetic energy of the electron, because you cannot destroy the energy or you cannot create the energy, but it can be converted from one form to another form. तो आपने potential energy provide की, ठीक है, potential energy, this is the again similar to the photoelectric effect, what sufficient energy is required to remove the electrons, and where the extra energy is going, that is converted into its kinetic energy, ठीक है, ये हमने पूरा डिटेल में पढ़ा हुआ. एक्चुअली इसी की बात यहाँ पे कर रहे हैं कि आप sufficient potential energy आपने अप्लाई किए, then the energy gain, now the electrons are traveling, that means they have already gained the sufficient potential energy to remove from the material. And now what is the, if you apply more potential energy, that means you are accelerating the electrons, and this we are going to actually explore over here. If you are going to accelerate or you can control the speed of the light simultaneously, it is going to depend on the wavelength of the electrons, सही है. तो ये अगर उसकी स्पीड को आप चेंज कर रहे हैं, एक्सेलरेशन को चेंज कर रहे हैं by using the potential, and this is going to change the wavelength of the electron. Clear है ये? And now we are going to explore how this is going to happen. Very simple equation. This we have already explained over here. So more potential energy you will provide. EV is the electron volt. It is the potential energy. More potential energy you are going to provide, it is converted into काइनेटिक एनर्जी, जितनी ज्यादा देंगे उतनी उसकी काइनेटिक एनर्जी क्या हो जाएगी, इंक्रीज हो जाएगी। क्लियर है ये? नो if you want to calculate the velocity, this was the important, actually यही acceleration की बात कर रहे हैं ना, तो उसमें से इलेक्ट्रॉन जो काइनेटिक एनर्जी बढ़ेगी तो वेलोसिटी के ऊपर जो है उसका डिफरेंस आएगा, एंड दिस वी आर गोइंग टू कोरिलेट विद द वेवलेंथ ऑफ द पार्टिकल। ठीक है, इसी को मेन ऑब्जेक्टिव ये है कि इसकी आप वेवलेंथ और वेलोसिटी का आपस में, या वेवलेंथ और पोटेंशियल का आपस में वोल्टेज रिलेशनशिप हम निकाल रहे हैं कि वेदर दे आर डायरेक्टली प्रोपोर्शनल और द इनवर्सली प्रोपोर्शनल बाय यूजिंग वेरी सिंपल इक्वेशन। तो ये हमारे पास क्या, वेलोसिटी आपने निकाली, तो दिस इज 2 इज गोइंग टू मल्टीप्लाई me is going to me is the mass of the electron। ठीक है, me is going to divide, and if you want to remove the square you can take the under root of this equation। तो ये घर में जाके आप स्टेप जो है साथ साथ भी लिख सकते हैं, कोशिश करें, क्योंकि यहाँ पे वो इट इज डिफिकल्ट टू अंडरस्टैंड, लेकिन आपने साथ उसका स्टेटमेंट लिखें, व्हाट आई एम गोइंग टू एक्सप्लेन ओवर हियर। ठीक, जहाँ पे नहीं आप उससे पूछें कि ये आपने एक्सप्लेन नहीं किया। If I have explained all these steps, now this is your duty to write your own notes। ये कहीं बुक्स में ऐसा नहीं मिलता, वहाँ तो इक्वेशन के बाद एक इक्वेशन जो आपके पास आई। See, now if it is the, you can also calculate the, I'm going to calculate the momentum. Why I am doing this one? Because the broglie equation is the relationship between the momentum and the wavelength. So I am just replacing the velocity by using this equation to put into the momentum. Momentum is the mass into velocity to get the final equation। तो ये भी आपके पास देखें, mass into velocity, तो I am just going to multiply the mass over here। ये second step में आपको और बता। So this is the momentum is the mass into velocity। So if you put the value of the velocity over here, ठीक है, यही जो आपने निकाली यहाँ पे, so mass into velocity, and then आपके पास मैथ इधर आपके पास आ जाएगा, मैथ ही आपके पास इधर आ जाएगा। ठीक है, सो एक्चुअली आई हैव शोन ओवर हियर, एक मैथ आपके पास अंडर स्क्वायर के अंदर है, अंडर रूट के अंदर है, एक मैथ आपके पास बाहर है। तो अगर आपने इसको अंदर लेके जाना है तो दिस विल बी m स्क्वायर ओवर अंडर रूट, दैट इज द सेम थिंग। ठीक है, बिकॉज 2 is going to cancel out, that means this and this are the same thing, there is no change। क्लियर है, ये समझ में आया? हाँ जी बताएं। m equal to m square under root, is there difference between this m and m square under root? No difference. Why? Because this is going to cancel out। And why we are going to do this one? Because our whole equation is under root, so we want to make it simpler। आप लिखने को कह सकते हैं, इधर भी आप m लिखते हैं, इसको वैसे ही रहने दें, that is the same equation। ठीक है, लेकिन m जो है एक ही इक्वेशन के अंदर बार बार जो है ना, कहीं पे भी दो फैक्टर, एक ही फैक्टर बार बार हम नहीं लिखते, उसको एक ही फॉर्म में लेके आते हैं। तो that mean I am going to make it more simpler to convert this math into this one। अब आप देखें आपके पास क्या होगा, let me first finish this one। m स्क्वायर अंडर रूट, तो दैट मीन इसको अंदर लेके जाऊंगा तो m स्क्वायर हो जाएगा। ठीक है, अंडर रूट इज ऑलरेडी देयर, तो m स्क्वायर एक m से कैंसिल आउट हो गया, बाकी ऊपर आपके पास क्या आ जाएगा, m आ जाएगा। सो दिस इज एक्चुअली द m, ये e बीच में स्किप हो गया मुझसे। ठीक है, सो मास इनटू वेलोसिटी विल बी इक्वल टू 2m, दिस इज द, इसको करेक्ट करेंगे, दिस इज द electron volt and this is the mass of electron। okay, clear? This is the equation, and what I have used over here, these are the steps to convert into this form। So according to the de Broglie equation, actually here I have calculated the momentum will be equal to this one। So de Broglie equation is lambda, this we have already derived, h over, this is rho, this is the momentum, as we have already mentioned over here। So momentum, up now put the value of this momentum in de Broglie equation। momentum आपने already निकाला हुआ, इसकी वैल्यू यहाँ पे पुट करें, and this would be the final equation। आपके पास h ऊपर है, म्यू आपके पास क्या है, म्यू इज, सॉरी म्यू का rho is this is going to divide, and the equation will be lambda will be equal to h under root 2 me electron volt. Clear है ये? So there is no complication in this equation. I am just, because I have, what is the purpose over here? The main objective is to convert the de Broglie equation by using the velocity of light, electron accelerating in the electrostatic field. ये इक्वेशन वही है, वहां पे velocity of the electron है, velocity of electron, that means it is having some direction, but here this is going to accelerate with the application of the electrostatic force, and this is called the electron volt. Potential आपने apply किए, and this then the electron is going to accelerate, and I have equated. Now the final equation is de Broglie. This is also de Broglie equation, but modified de Broglie equation by using the electrostatic potential. And now this is the electronic charge over here, उसके ऊपर जो भी है. Now let's see now the final output. If the potential is more, then this will be small, wavelength would be small, ठीक है? Or if this is large, and sorry, again is if the electron volt or the electrostatic potential difference is more, the wavelength will be small. ठीक है, यही हमने लिखा है कि जितनी आप पोटेंशियल ज्यादा अप्लाई करेंगे उतनी एक्सेलरेशन आपके पास क्या आएगी, ज्यादा आएगी, फ्रीक्वेंसी ज्यादा होगी. व्हेन देयर इज मोर फ्रीक्वेंसी, दैट मीन देयर शुड बी अ लेस वेवलेंथ. दिस वी हैव ऑलरेडी एक्सप्लोर्ड इन द फोटोइलेक्ट्रिक इफेक्ट. अब ये इसमें है. नाउ यू कैन कंट्रोल द वेवलेंथ of the electron with the applied potential. Actually this is the application of this equation. Light को आप नहीं कर सकते, ठीक है, because light does not has the charge, but the electron is having the charge. That's why you can control the acceleration or the speed or the velocity by using the applied potential. And this is the relationship between the wavelength and the potential. These are inversely proportional to each other. अब आप देखें, आपने जो पहले हमने इसको, आप जितना ऊपर जाएंगे, that mean what would be the, if you need a small wavelength, that mean you will need high potential. सही, more potential you will need to accelerate the electron that is having the small wavelength. That means now you can see if the, like if you want to see the atoms, that means now you must have at least the wavelength in this region, and this is in nanometers. ठीक है, या आप एक्सपोनेंट 9 से मल्टीप्लाई करें 0.1 नैनोमीटर आएगा. सही, इसी तरह आपके पास 9, 10, ये 100 नैनोमीटर आपके पास है. दैट मीन अगर आपने ये, हम नैनो टेक्नोलॉजी का स्केल अगर आपने इसमें देखना है, यू मस्ट having the range of the wavelength with this region. ठीक है, तो यहाँ पे एक्सरे भी है. ठीक है, इसको आगे को रिलेट करते हैं. नाउ व्हाट इज द डिफरेंस बिटवीन एक्सरे एंड द अदर, दिस इलेक्ट्रो the wavelength generated by the moving of the electrons. ठीक है, this we have finished. Now just let have a first finish this exercise. Very simple, जितनी भी आपको बता रहा हूँ जस्ट अंडरस्टैंडिंग के लिए बता रहा हूँ आपको. लास्ट टाइम भी हमने किए, जो इसमें कैलकुलेशन में आपके पास आती है वो थ्योरेटिकल में आपके समझ में नहीं आ रही होती. ठीक है, तो what is the wavelength of the electron when it is accelerated by 1.0 exponent 3 volt. That means 1000 volt के ऊपर आपने पोटेंशियल दी है और इसको एक्सेलरेट कर रहे हैं. What would be the wavelength? करें, कैलकुलेट करें. Which equation you are going to use? शाबाश बताएं. मॉडिफाइड जो अभी की है यही इक्वेशन. आप देखेंगे कोई दूसरा फैक्टर इसमें है ही नहीं. Just there is the relationship between the wavelength and the potential. बच्चे आज आपका पहले कब आपने, अच्छा चलो. चलें ये देखें, दिस इक्वेशन वी आर गोइंग टू यूज एंड दिस इज द सॉल्यूशन। लिख लें इसके ऊपर जो अगर आपने नहीं लिखा हुआ 6.626 या 6.3 exponent minus 34 joule per second and 2 is constant 9.109 exponent 31 kilogram is the mass and this is the charge of this E electron charge यही होता है 1.602 exponent minus 19 coulomb and this is 1000. This is the voltage which is given over here. So you just are going to multiply all these and divide this by using this. ये unit conversion का आपकी आसानी के लिए always remember when unit conversion is most important. ठीक है, तो ये कूलम जो है कूलम मल्टीप्लाई वोल्ट इज इक्वल टू जॉल। तो जॉल आपके पास क्या है किलोग्राम मीटर स्क्वायर पर सेकंड स्क्वायर। तो ये रखेंगे तो सारा कैंसिल आउट हो जाएगा। ठीक है, अंडरस्टैंड करने के लिए बताया हुआ। Now this is 3.88 exponent 11 मीटर। आप माइनस में वैल्यूज बता रहे। हाँ, किसी की भी नहीं आई वैल्यू आपकी, आपने बताया था -11 है, ये तो 11 एक, हाँ ये -11 मीटर। व्हेन यू मल्टीप्लाई एक्सपोनेंट 9 this will be converted into nanometer. Exponent 9 multiply -11 9 10 11 सही है। तो -2 आपके पास आएगा। -2 को जब आप रिप्लेस करें तो 0.03 हो जाएगा। ठीक है, 3.88 multiply by exponent -2 that will be converted into 0.0388 nanometer. So both are same. Just if you keep the calculation over here, this is also correct. This is just the conversion. So actually we are discussing the how much shorter is the wavelength, and because the electrons are having the wavelength in the nanometer scale, that's why it is easier to remember or to compare the wavelength with the other electromagnetic radiation. So you should convert the meter scale into the nanometer scale, right? क्योंकि ऊपर सारी आपके पास नैनोमीटर में, तो इसको घर जाकर दें, इसको दोबारा से आप करें। लेकिन सिंपल आपके पास कैलकुलेशन है, थ्रू आउट हम करेंगे, इससे आपके अपनी इसको स्ट्रेंथन करें अपनी कैलकुलेशन में। इट विल ऑफ कोर्स इंक्रीज द IQ एज वेल। ठीक है, नाउ वी आर गोइंग टू कोरिलेट दिस वेवलेंथ with the that mean advantage of the electron microscope. That means this is what we have discussed in the previous slide. This is the development of the electron microscope, because we are using the electron to see the particles or the molecules. Over light microscope, that means you can see in the visible region, or you can use the X-rays. X-rays are near to the this electron microscope. So now we are going to compare all these two techniques with the electron microscope. So the first one is obtaining voltage in kilo, that we already calculated in the previous slide, the calculation, or even mega voltage, that means 1000 range is relatively easy, so very small wavelength can be achieved. So more will be the voltage, less or small will be the wavelength, and this is according to the broglie equation, which is written over here. These are inversely proportional to each other. So if you want to further decrease the wavelength, let's suppose in the previous case, so it should be, let's suppose if you want to further decrease the wavelength into 0.00388 nanometer, then what should you do? क्या करें? वोल्टेज बच्चे ज्यादा करें। ये आपको बार बार अभी ये लास्ट स्लाइड चल रही है, सही है, बिकॉज वोल्टेज एंड वेवलेंथ आर इनवर्सली प्रोपोर्शनल टू ईच अदर। एक्सप्लेन भी किया हुआ है, एंड बाय लुकिंग एट द इक्वेशन यू कैन आल्सो सी। ठीक है, तो आप क्या करें, और वोल्टेज क्या, और वोल्टेज अप्लाई करेंगे, एक्सेलरेशन और ज्यादा होगी, स्पीड और ज्यादा होगी, फ्रिक्वेंसी आपके पास इंक्रीज करेगी। फ्रिक्वेंसी इंक्रीज करेगी तो वेवलेंथ क्या होगी, डिक्रीज होगी। सही है, अकॉर्डिंग टू दी फोटो इलेक्ट्रिक इफेक्ट फिनोमिना जो है, उससे रिलेशनशिप आप डेवलप कर सकते हैं, बट हियर वी आर डिस्कसिंग द वेव लाइक प्रॉपर्टीज ऑफ द पार्टिकल। So thus an electron microscope differs from the light microscope which is working in the visible region. You can using this light to see the object. Like I am using the visible light to see to you and to see other objective objects. So in the light, visible light is replaced by the beam of the electron. So this is the difference. In the light microscope, you are going to use the visible light, but in the electron microscope, you are replacing the visible light with the electrons, and electrons now emitting the wavelength, which is having the much shorter wavelength as compared to the visible region. Clear again? Now, third point, this just I have concluded with this one. This much shorter wavelength produce better resolution. जितनी कम होगी उतनी resolution उसकी क्या होगी ज़्यादा होगी. मतलब उसको आप ज़्यादा minutely जो है उसको atoms को जो है वो दे सकते हैं. जैसे हमने पहली slide में देखा, you are looking the atoms or the molecule with some specific shapes, and this you can only use by using the electron microscope. And the next is this technique allows to see large molecules as well as heavy atoms. And the other one is with the X-rays. The major advantage of the electron microscope over the X-ray diffraction is that electrons are the charged particles and can be focused easily, thus imaged by the electric and the magnetic field. And because X-rays are the rays, these are not having the charge and you cannot accelerate or deflect by using the voltage. So this is the major advantage of the electron microscope over both techniques, X-rays and light microscope. So this is all about today's lecture. Maybe you can use this one and just write down, and in the next class you must bring this exercise. So this is all about the broglie equation, and we will move to the other topic in the next lecture.